Hello everybody, this is Unit 5, Day 3, and we are talking about geometric sequences. Okay, so the main thing you want to take away from arithmetic and geometric is arithmetic is a common difference, right? Which means that we are adding or subtracting the same amount from term to term. Okay? Now, geometric sequences, on the other hand, okay, they are exponential in nature. Okay, which means that if you were to graph these terms in the sequence, right? Remember, if you're graphing the arithmetic, they had a nice steady increase, right? Now we don't cross the line, or we don't connect the lines, but as you can see, it was very similar to a linear equation, right? Our slope, or our rise over run, is that common difference, right? What we're increasing by each time. Okay? And so, exponentials, whoops. Heyo, get out of there. Look more like this, right? Or, maybe they look more like this, okay? And again, very similar to that exponential curve, right? Except again, we aren't connecting the dots, right? So these geometric sequences look more like exponential equations, right? So geometric sequences have a common ratio, okay, which is the amount multiplied from term to term. So that's the difference between arithmetic and geometric, okay? Geometric, we are multiplying by the same amount from term to term, and arithmetic, we are adding, quote unquote, subtracting, right? Adding a negative number or adding the same amount from term to term, okay? So, anyway, here is the formula, okay? And so, a to the n still represents your nth term, okay? Or your formula utilized to find any term in the sequence. All right, a sub 1 is still your first term. And r is your ratio. And then again, n is the number term in the sequence. Okay? So when you see this 1 here, right, that represents our first term, right? That n in the corner always signifies what term in the sequence we're talking about. Okay? Forget this guy. All right, I will show him in class. Okay, so make sure if you're not comfortable with regression, or you don't remember, or maybe I forgot, or for whatever reason, okay, make sure to bring this one up. Okay, I'm pretty sure I'll probably remember to demonstrate this in class, but make sure that when I do, you guys are taking notes and paying attention to this, because it's rather simple, right? It's not a hard process. You just got to be shown how to do it, right? Like anything, right? I can't just, all right, hop in a car and drive, right? Well, someone's got to show you a little bit how to drive, right? Otherwise, you're not going to know the rules of the road, right? So same thing here, right? I don't think what I'm going to show you is hard, right? It's kind of cool in the sense that your calculator does the work for you, right? And I think it's always important to have that sort of backup plan to be able to check. But for the video here, we're going to be focusing on the algebraic method for finding these sequences, okay? So just keep that in mind, all right? So anywhere where it says exponential regression or use your calculator, okay, that's what we're referring to. So if you're watching this and you're starting the homework and I haven't demonstrated this in class, don't worry, okay? I will make sure to do that when you guys return, right? So the only people I haven't shown so far is the red group, and so they'll be here Thursday, Friday, and so you'll get a good taste of that. All right, so the graphs, like I said, are the same as for the arithmetic, right? We're only concerned about the points only, right? And that's because when you connect the points, right, well, that means you're worried about the stuff in between. And we're not. We're only worried about the term in the sequence, right? What is our pattern? What are we multiplying by each time? Okay? And then our domain and range, again, are the, same as it was from the arithmetic. Your domain is kind of like your term number. And then your range is the actual actual number in the sequence. Okay? So that's how you kind of want to think of these. Your range is the sequence, right? What's as we're going from one, first term to second term, third term, fourth term, as we're changing our terms or our quote-unquote x values, right? What's happening to our y values? What are we increasing or decreasing by, right? In this case, we're multiplying, so that's what we have to pay attention for. So anyway, here's our first taste of a geometric sequence, right? So a sub n is equal to 3 times 2 raised to the n minus 1. Okay, so 3 is our first term. I might put an I there. Hey-o. A sub 1. And then that is our ratio, right? What we're multiplying by each time. Okay, so let's find our first 5 terms. Now we know the first one should be 3, but let's see if that's what we come up with. So I get 3 times 2 raised to the 1 minus 1, which is 3, times 2 raised to the 0, which is 3 times 1, which is 3, which I'm happy with. Okay, this is going to be 3 times 2 minus 1, which will be 3 times 2, which will give us a 6. 3 to the second, or 2 to the second power would be 3 times 4. That'll be 12. 2 to the third power would be 3 times 8. 24. And hopefully you're starting to see the pattern. 2 to the fourth, that, am I drawing a blank here? 16. 16 times 3 is 48. Okay, so here is our sequence of numbers. And as you can see, as we go from term to term, we're multiplying by 2. So we're doubling each time. Okay, and so here's our list of domain numbers, right? 1, 2, 3, 4, 5. And here's our list of range numbers: 3, 6, 12, 24, and 48, ... because numbers go on forever. Okay, so now let's graph these guys. 1 is going to be 3, 2 is going to be 6. Don't connect them, and, well, 12 will be up here somewhere, right? But anyway, that's what it would look like. Okay? All right. So let's get down to some nitty-gritty here and do some math. So this looks very similar to your arithmetic sequences. Actually, these are the exact same 4 sequences we had there, right? Just in the last one, 2 of them weren't arithmetic. 2 of them were. All right? And so in this case, 2 of them aren't geometric and 2 of them are, right? So kind of split half and half, right? So take a look at 1 and 3, right? Clearly we're subtracting 2, minus 2, minus 2. This one's adding 5, adding 5, adding 5, right? And you should remember that from the previous lesson. If you don't recall seeing these two, well, go back and give it a look, right? So this is arithmetic, and this is also arithmetic. Okay? And so that's all we're going to have to do for those, right? Because B and C, well, C will skip, right? I'll show you how to do this in class. So ignore that for now. I'll make sure that you guys are comfortable with that by the end of the week. Right? So we'll just kind of skip that piece for now, and we'll just worry about the algebraic method. Okay? So take a look at 2 and 4, because those are definitely geometric, right? So take a look at 2, right? From there to there, it looks like we're multiplying by 3. From there to there, multiplying by 3. And from there to there, multiplying by 3. All right, so definitely geometric. Okay? However, take a look at number 4, right? And it's kind of tough to tell, right? We're dealing with some fractions here. Now, it is geometric, and one method that you can use, you know, kind of very similar to the arithmetic sequences, right? In order to find that common difference, maybe it doesn't come out as, maybe it just doesn't look as obvious, right? And so what you do is you take the last term and subtract it from the term previous. We get a 5. 16 minus 11 will give me a 5. And 11 minus 6 will also give me a 5, okay? So that's another way you could verify that it's arithmetic, right? We're going up by 5 each time, right? So the same sort of process kind of happens here, right? Except, actually I'll bring that back. Whoops. Trying to shrink it. There we go. All right. Except we're not going to be subtracting, right, because we're multiplying each time by a common ratio. We're going to divide 132 by 1/8. Right? And so when you do so, you end up getting 0.25, or 1 over 4. And then if you did the same thing for 1/8 divided by 1/2, it would also give me a 0.25, or 1 over 4. Okay? And so, now that you're kind of seeing that, now it looks a little more obvious, right? It looks like we're multiplying by 1 over 4 here, and 1 over 4 here. So, our common ratio is 1/4, and so we have all the information we need. All right, so I'm going to write this up above. A to the n is equal to your first term times your common ratio, n minus 1. And then down here, this is going to be 1 times 3 raised to the n minus 1. All right, and then the last question is asking us to find the 10th term. All right, so anywhere I see an n, I'm going to put a 10. 10 minus 1 is 9. And 3 to the 9th power, gosh, I feel like I've done it a couple times today. I should recall. Guess I'll have to work on that. 19,683. And that is our 10th term in the sequence. And then over here, we zoom in. All right, so this is going to be a sub n is equal to 1/2. Oh, I'm sorry, we're looking for the 10th term, right? One half times 1/4. 10 minus 1 is 9. All right, so 0.5 times 4th raised to the 9th power. And you get this, 1.91 e to the negative 6. That e is just a 10 to the negative 6. So, if we wanted to put this in actual terms here, we're going to take this decimal place and we're going to go back 6 times. So 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5. Cool. And so that, whoops, will be the actual number. Whoa, no wonder why that's, the eraser's huge. There we go. Okay? Either one's good though. All right. Finally, let's wrap up this last part here. So, again, I will show this in class. All right, so this involves regression, so we'll take care of that in class. All right, so this last piece, okay? This is how you want to think of these. Now, they They want us to come up with the nth term, right? They want us to come up with the formula for each of these guys here. Okay, so there's our formula. All right, so as you can see, in both cases, we're missing our first term. So we're going to have to find that. Okay, so again, no wrong way to eat a Reese's, right? I'm going to show you one way. I'm going to show you another way. And I'm going to let you decide which one you think is the easiest. Okay, so to get from here to here, we multiplied by 3. To get from here to here, multiplied by 3. Here to here, multiplied by 3, right? So in order to get back, we're going to divide by 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 will give me a 0.3333, or just a 1/3. So there's our first term. Okay, and so a sub n is equal to 1/3, 3, and minus 1. Okay, that's not the only way to find it. Okay, the other way we could find it is this. All right, let's take into account how many times did we multiply by 3? 3 times, right? And so that's 3 cubed, which is 27. And then we take this number, we divide it by whatever number we come up with, in this case 27, and that ends up being 1/3, which is our first term in the sequence. Okay? So that's however you want to think about these guys here. Okay? I'll accept either method, right? As long as you get the right answer. Okay, so this last one. All right. Again, let's do the same process. 6, 5, 4, 3, 2, 1. Okay? And so from here to here, we multiplied by 3/2. Here to here, 3/2. Here to here, 3/2. 3/2. 3/2. Okay? So, in order to get back, we're just going to divide 12, like we did in the last one, by that common ratio. 3 divided by 2 will give me an 8. All right, 8 divided by 3/2 gives me a 5.3333. I don't want to use that, so I'm going to math frac that guy, and that'll give me a 16/3. Okay? Take 16/3. Now make sure you're putting these fractions in parentheses, otherwise you're going to run into some trouble. So when you do 16/3 divided by 3/2, okay, well that gives me 3.555. Math frac, 32/9. Divide that by 3/2. Math frac, 64/27. Divide that by 3/2. Math frac, 128/81. Okay, so here's our first term. So let's write it in. A sub n is equal to 128/81 times 3/2 raised to the n minus 1. Okay, maybe you didn't like that method. So how many times did we multiply 3/2? Well, we multiplied it 5 times. So raise it to that power. So, 3 to the 5th. Man, 243. There it is, 243. 2 to the 5th is 32, I believe. Yep, that's definitely it for sure. So then we take that number and we divide 12 by 243/32. And we should get our first term. Let's verify those. So 12 divided by 243. Math frac that bad boy. Bada bing, bada boom. Okay? So anyway, a couple ways you could figure that out. Okay? That's clearly up to you. I will show you the regression part on your calculator when you guys return to class. And so hopefully you found this helpful. And have a good day.